Hey guys, today we're going to take a look at extending our knowledge of transformations that we previously talked about. And we're going to now go from graph to equation. So in our previous lesson, we worked on going from equation to graph. Now we're going to figure out how to achieve the equation of a sinusoidal function given the graph. So a couple things that we need to know firstly are the amplitude formula, which is going to be max minus min over 2. The vertical shift or displacement formula is actually very similar to amplitude, so we can find that center line of the graph or the midline by adding max and min and dividing by 2. So this formula should be a little bit familiar to us in a sense because it's kind of how we take the average of two things. So if I want to know the midline or the center line between the max and min, what I actually want to do is add together those two values and divide by 2, similar to how I would take the average of 2 marks that I got on a test to give me my overall average of the course. And then a lot of times we refer to period with the letter B. So if you see that in your travels, that's representing the period of the function. And remember that the period of the function is the horizontal distance of one cycle. So, I'm sorry, this should say in degrees. Just realized. So one full cycle. So I can rearrange this formula in 2 different ways. So I can find K if I do 360 over the period, or if I have the period, I can do 360, or if I have the K value, I can do 360 over K to find that. And then finally, D represents our phase shift, and this is going to require a little bit more knowledge of sine and cosine. So for D, if we think about the regular sine function, here it is, here's one cycle, and this is going by 90s, every point here. Now the regular sine function starts at what we call a rising midline. So if this is our midline, it separates kind of the middle to the max and the middle to the min. This is typically on c equals 0 if there's no transformations whatsoever to our regular sine graph. And you'll notice as you move left to right here that this point right here is what we call a rising midline because the graph is rising from the midline. I know, crazy. So this point right here, if I'm trying to find a sine function for my graph, that's what I want to find. So what I'm going to do is I'm going to make sure I draw out this midline here with a dotted line every single time that I find it. And then I'm going to trace along that midline to find where it starts rising as I move left to right. So that's the idea. So we're looking for the rising midline for sine. And then if we look at cosine, the cosine function, let me just delete that. The cosine function starts at a maximum. So here's our cosine function. And this is again going by 90s. And so on. And you'll notice here that cosine starts at a very max point. So in order to find the d value shift or the left and right shift, I want to look along my graph and find the location of a maximum. And how far that lies from the y-axis. Okay, so if I shift my graph left or right, my maximum is actually going to shift as well. So for cosine, I always want to look for where that maximum is. Okay, so for our first example here, we're going to take a look at this graph. And we are actually going to find a sine function and a cosine function for this one. Okay, so let's start by identifying our max point and our min point. So I'm talking about the y values of those. So max looks like here is 3, and minimum is -5. So I can now use both of these in our formulas above for amplitude and the midline, or the c value, to find a and c. So the first thing that we'll find is A, and that's max minus min over 2, which gives us 8 over 2. So we get 4. Okay, so I'm just gonna write that over here and box it up. We'll need that in a couple minutes. Second thing here is we can find the c value by doing max plus min over 2. So 3 plus negative 5 over 2 should give us negative 2 over 2, which gives us negative 1. Now this is our midline of the graph, so we're actually going to go over here and just pencil in kind of a dotted line right along here. And if I've done it correctly, it should basically separate mountains from valleys, and they should look like they're equally split apart here. So if your midline ends up being like somewhere up here and you have way bigger valleys than you have mountains, that's probably just indicating to you that you've calculated it incorrectly. Okay, next we're going to do the k value. So we can find the k value by doing 360 over the period, which we referred to as b. And period can be measured in a bunch of different ways. So we talked about this in our last lesson. But the period of a function I can measure from min to min, I can measure from max to max, or I can even start on a midline and measure one full valley and one full mountain. And I think that's actually the easiest way to measure the period here. But if you're ever not sure, you can try measuring it in a couple different ways and see if you get the same answer. So it looks like here, if this is starting at 0 and going to 120, looks like our period would be 120. And that means that k ends up being 3. Okay, this is the actual k value. You don't have to do the reciprocal or anything when you plug it in. Okay, and then lastly, we're going to find d of sine for our sine equation, and then we'll also find d of cosine for the cosine equation. Okay, so for d of sine, here's the idea. I'm going to trace my pencil. So remember, we drew this midline here. I'm going to trace my pencil along there until I hit a rising midline. So I want to be coming from the midline and actually going up into a mountain. So you can actually see that it happens right here. This is my rising midline. This is the point on the midline where if I move left to right, I'll actually start rising up into a mountain. And where does this happen in relation to the y-axis? Well, it happens at 60 degrees to the right of the y-axis. So we're going to say that our d of sine is 60 degrees right. Now there are actually infinite answers for this because there are infinite rising midlines. So if we look at maybe another option here, another option could be this is also a rising midline. So I could also say 180 to the right. Another option could be to the left of the y-axis. I see one that's like right here that looks like it's at negative 60, and that's also a rising midline. So lots of different options here, in fact infinite options, because this is a periodic function that continues in both directions forever. Typically I'll just choose the closest one. However, there's no wrong answer as long as it actually is a rising midline that you found. Okay, and then for d of cosine, we're looking for the nearest max to the y-axis. So, and again, it doesn't necessarily have to be the nearest one, but I'm seeing that there's one that's pretty close here, and if these are going every 2 is 60, that means that this must be negative 30 here. So I'm looking for this space in between the maximum and the y-axis right there. So I can say 30 left for this one. I want you to think about where another possibility could be for our shift for cosine. Where does another maximum occur? Okay, so if you're noticing that there's another maximum also here, this actually occurs at 90. You could have also said 90 to the right. Okay, and this is of course, in relation to the y-axis. Okay, lots of different options. You can also use this one as well. So any maximum, typically I'll just choose the closest one, but any maximum will do for this. Okay, and now we're just basically going to put our formulas together. So let's call this f at x. I'm going to plug in a first, which was 4. And we'll start with sine. So our k value is 3. Remember, the k value needs to be always common factored out from your x value. C is -1. And when I want to put in 60 right into my equation here, I know that that actually kind of like switches signs because there's already a negative that exists there. So you're going to plug that in as -60. Okay, and another way to express this would be as a cosine function. And that means that the only thing that's actually different about these two things is the shift here. And I'll talk more about that in 1 second. So if I want to say 30 left, I will say plus 30. Okay, you can also put in here minus 90. That would work as well. Okay, so the thought is that actually every single sinusoidal function can be expressed as a sine function or a cosine function. So I'm going to hop over to Desmos just to give you a visual as to why that is. All right, so here I have set up for you the graph of sine x, which is our red graph here, and also the graph for cos x. So you can actually see that these graphs are actually very similar. When we talked about some of the properties in our previous lesson, we were talking about how they both have an amplitude of 1, they both have a period of 360, and they're kind of really just shifted versions of one another. So if I took cosine, the cosine function here, and I actually shifted that graph right 90, or sorry, left 90, I should, right 90 is minus 90. These graphs actually overlap. So they're really just 90-degree shifts of one another. Now, of course, that kind of changes if we do stretches or compressions in the horizontal direction. But yeah, these are really just shifted versions of one another. So when I'm looking at the function or the equation for the graph that we just did, I can actually express this in many different forms. I can express this as sine or cosine with many different d-value shifts for both of these because they're periodic functions. So I'm actually going to show you in Desmos here how these two functions, even though they look different, are actually producing the same graph for us. All right, so I've graphed both functions, as you can see over here in my little legend. And you can actually see if I make one of them disappear, they're actually exactly overlapping graphs. So we can actually see visibly now that these two functions are actually producing the same graph for us. All right, so we're going to, in example 2 here, express this as a sine function. And once we go to the next one, I'm going to kind of give you like a little trick when you can't exactly see the maximum or midline, but you can see the other one, as to how you can use that to find cosine. And what I mean by that is if I were trying to find the location of the max here, that's actually a little bit difficult because this doesn't fall exactly on like an exact cross section. But I can see the rising midline. So if I know one of them, I actually have a little trick formula that will help you get the other one. So we'll do that in the next example and then we'll come back to this one. All right, so just for now, we're going to do the sine function and I'm just going to erase this. So let's start with finding the y location of the maximum. And that's going to be here, which is at 5. And then we're going to find the minimum, which is at 1. And we're going to use both of these to find the a value and the c value. So a is max minus min over 2. That's going to give us 2. I'm just going to box that up. And the c value, this is going to be max plus min over 2. Whoops, should be 5 plus 1 over 2, and that gives us 3. And as soon as you find that, remember this is the midline of the graph, and this is going to help us find our d of sine. So we're always going to go over to our graph and just pencil that in as just a little dotted line there. Okay, and if I found it correctly, it should look like my mountains are as tall as my valleys are low. Okay, let's find the k value. This is going to be 360 over the period, so we need to find the period of our function here. So I think the goal here would be find something where you can start on an exact cross section. So here max to max isn't really going to work for me because I don't know what those points are. Also, min to min is kind of the same deal. I don't really know exactly what those points are, so I can't use min to min. But I could use midline. This looks like it starts on 30 degrees here. And if I look for one whole mountain and one whole valley, that's a full cycle right there. So that is the length of the period. So it goes from 30 to 120. So how many degrees between 30 and 120? It's actually 90 in between there. So just do 120 minus 30. Okay, so we're doing 360 over 90. That's going to give us 4. Okay, so we'll box that one up as well. And then lastly, because we're just finding a sine function here, I'm just looking for the d of sine, which is that rising midline. So we're going to trace along this green line, this c value line, and see if we can find the location of where we're rising up into a mountain. Okay, essentially I'm looking for the left side of that. The right side of a mountain, that's heading down into a valley, but the left side of a mountain, that's heading up into what we call rising midline. Okay, and that's happening right here. So we can say 30 to the right. Can you find any other options? Okay, I think this guy over here is also a rising midline. I think this is negative 60 over here. You could have used 60 to the left. You can also use 120 to the right. That's also another rising midline. Lots of options there. Okay, so let's plug this into our formula now. We're going to enter amplitude, and this is a sine function, so I want to make sure I say sine here. K value needs to be, oh, I accidentally put the K value as 3 there. K value needs to be common factored out. And if I want to say 30 right, I'm going to say minus 30 inside here. And the C value is positive 3. Okay, so there's our function. And once I show you the little trick in the next, we'll actually come back and use that to calculate the d value of cosine, because we can't really see that exactly here just yet. Okay, so another way that you might be asked a question like this is you might be asked to come up with a sinusoidal function. Sorry, this should have an I in there. Sinusoidal simply means sine or cosine. Just means it's one of the periodic wave functions. So sinusoidal function, it has an amplitude of 3 units, a period of 180 degrees, and a maximum at 0.5. So this is going to give us actually information for C and information for D. And we're going to represent this in 2 ways. So when we say 2 different ways, we're really just meaning as a sine function and as a cosine function. Okay, so kind of the easy ones here are if we have an amplitude of 3, that means A is 3. And I can also calculate K by doing 360 over the period, which is 180 here. So that gives me a K value of 2. And it says maximum at 0.5. So maximum, we talked about how the maximum value actually gives us information about the cosine function. And that's because cosine usually starts at a maximum. So when we try to find like d of cosine, we're looking for the nearest max, right? So we were looking at these points here. So this question is actually giving us information about the location of that maximum. So if it helps you, you can kind of just like draw a bit of a picture here. And we have a maximum up here at the point 0.5. So our maximum is up here, up at 0.5. And the amplitude is 3. So the amplitude tells us information about how far we need to count down to get to the midline. And then if we count down even further than that, we'll hit the maximum. So if I count down 3 units from 5, I actually should hit the midline of my graph. So 3 units down from 5 is actually 2. And that's actually going to tell me my midline. So counting down the amplitude of 3 units, I should hit my midline. And then if I counted down 3 more units, I should actually hit the minimum of the graph. So the minimum of the graph would be at -1. So my graph somehow just, it kind of goes like this. I don't know exactly, but something like that, right? The minimum's down at -1, the midline's at 2, the maximum's at 5. And because I'm given information about the maximum, I should actually start my information here with a cosine function. The x value here actually gives me information about the d of cosine, and the y value actually gives me the max. Okay, so always look for the d value as your x value of the maximum. So d of cos here, and I know it's cosine again because this is information about the maximum rather than the rising midline. The d of cos is actually 0, and we calculated the c by basically doing the max value minus the amplitude. So count down the amplitude from the maximum and you should hit your c value. So c should be 0 here. C should be 2. Okay, so when we create the equation for this, we're gonna create it as a cosine equation to start. In this case, actually, because our d value is 0, we can basically just write this as 2x, like so. And we'll do plus 2. Now, here's the question. Where is the closest rising midline? So if I were to kind of continue my graph over this way, I know the midline is actually always to the left of a maximum. That just makes sense because a rising midline is going to rise up into a maximum to the right. So the rising midline is always going to be over to the left of a maximum. And we need to kind of go back to what we talked about previously, and that is, how are the graphs of sine and cosine connected? Well, the graphs of sine and cosine, as you saw on Desmos, they're just 90-degree shifts of one another. But I did say earlier that this can be impacted by any stretch or compression that has happened in the horizontal direction. So here you see that the k value is 2. This means that there's actually a horizontal compression by a half. So now what once fit in 360 degrees, the full cycle, now I've compressed it by a half, and one cycle actually fits within 180 degrees. So instead of sine and cosine being 90-degree shifts of one another, now that I've compressed them by a factor of a half horizontally, they're actually 45-degree shifts from one another. So the kind of summary of this and how we can use this to shift between sine and cosine is this. If I have a cosine equation and I want to translate that into a sine equation, what I'm going to do is I'm going to say I'll find the new d of sine by taking any existing shift of cosine. So we'll take the current d of cosine, and we are going to go further left by 90 degrees, but I need to consider any stretch or compression that has happened. So I'm actually going to take that 90 and divide it by whatever k is. So in this case, k was 2, and I said that because we compressed by a half, instead of a 90-degree shift, it was actually a 45-degree shift. So I found that by simply doing 90 divided by 2, which gave me that 45-degree shift. Okay, so if you get a positive answer out from this, that's going to be telling you that you have a right shift. And if you get a negative answer out from this, you're going to be getting a left shift. Okay, so that's basically how we'll do that. And alternatively, if you're going from a sine equation to a cosine equation, you will find the d of cosine by doing something very similar. You're going to take the existing d of sine shift, and you're going to add 90 over k, and that's because the d of cosine is further to the right than the rising midline. Okay, so this is kind of your little summary. You can box that up, you can highlight it, whatever. And if you want to memorize it, you can. It's good to understand it, but if you're confused, you can just have that, and that will help you shift between the two. So we're going to use this on this one, and then we're also going to go back to example 2 and use that as well. So if I'm going from a cosine to a sine equation, I'm going to use that first formula, and that was that I can find the d of sine by taking the d of cosine and subtracting 90 over k. So in this case, our d of cosine is actually 0, and we're going to subtract 90 over k, which is 2 here. So we're going to get a negative 45, or in other words, we get 45 to the left. And if we look at our picture, that actually makes sense, right? Because we know that the rising midline is over here. It's to the left of the y-axis, so we're saying that this is basically at negative 45 over here. So when we create our sine function, everything will remain the same, except of course I'll change cosine to sine, and then I want to have my new d value in there. So we're going to do 2, and it will be x plus 45. So remember to change that sign in there. And that should give us our sine function. So now we've expressed it in 2 different ways. So I want to go back here, and we're going to see if we can now figure out the d of cosine now that we have a sine function. So d of cosine. This should be equal to the current d of sine plus 90 over whatever the k value is. So our current d of sine is positive 30, and our k value is 4. So what we're going to get from this is basically 30 plus 22.5, and that's going to give us 52.5, or in other words, it gives us 52.5 to the right because we've got a positive value out from that. Now, does that make sense? If we look at our graph here, does this look like it could be around 50? I think it does. It's between 30 and 60, but a little closer to 60, so that makes sense. So if we were to write this as a cosine function, we'll of course change sine to cosine. Sometimes people forget to do that, so don't forget that part. We'll have our k value the same, c value the same, but in order to express the new d of cosine, we'll use this 52.5 to the right. So it will be minus 52.5. That would have been pretty much impossible for us to actually find by just observing the graph, but because I could see an actual midline value on an exact coordinate, this little formula kind of helps us with that. All right, so let's try another example here. A sinusoidal function, again, I'm missing the I there, has an amplitude of 2 units. I'm going to underline that. A period of 90 degrees and a maximum at 0, -2. Represent the function in 2 different ways. So we're going to represent this as sine and cosine. And because I'm given information about the maximum here, I'm going to start with cosine. If you happen to see in this type of question, if you see rising midline, then you can start with a sine function. But most of them will probably give you information about the max. So here's what we know so far. Amplitude is 2. That means A is 2. Period is 90, so I can use that to figure out our k value, so that should give us a k value of 4. Maximum is at 0, 2. So we talked about how the 0 gives us d of cosine. So the x coordinate of that maximum, that one's going to be 0. And the y coordinate of that maximum, actually gives us the maximum value, and the maximum value is -2. So if I know that I have a maximum value at -2, let's say it's right here. If I count down the amplitude from that, that would be 2 units. I will actually hit the c value line, and that's going to be at -4 here. Okay, so our c value is -4. So we have something that kind of looks like this. Okay, and the minimum, if you want to figure out the minimum, you don't really need it, but if you counted down 2 more units, we would get the minimum. So that should happen at -6. Okay, so let's set up our cosine function here. We'll call this r at x. It's going to be 2 cos, and because the d value is 0, we'll just write this as 4x, and then -4 for the c value. And then we're also going to come up with the d of sine as well. So d of sine equals d of cosine. And we can actually visibly see here the rising midline is further to the left, so we want to subtract 90 over k. So d of cosine is currently 0, and k is 4. So this should give us negative 22.5, or in other words, we're saying 22.5 to the left. So let's plug this into our sine equation. Same amplitude, switch cosine to sine, same k value, leave a little bit of space there, same c value, and then we want to say 22.5 to the left. So when we plug this in, we should be doing plus 22.5. Okay, and there's our two answers. Okay, and you can always go, if you're unsure, you can always check with graphing software and make sure that your two equations are overlapping one another, that they're the same.